Hello, welcome to chapter 5. Today we have a new video. I have a microphone. Please let me know if the audio sounds better without the microphone or with the microphone. I hope you can hear me better now. So, chapter 5, we're going to go over question 66, R or S of chirality centers. So, R or S consideration of chirality centers. So, whenever you have something going to the right, to your right hand, it's going to be a R configuration. And when you have something with your left hand going to the left, it's going to be a S configuration. So right, and the other one is going to be S, left. Right? So something to remember, chirality centers are sp3 hybridized. We talked about it in the last video. You're going to have sp3 hybridized. Right? If you have a double bond, that's sp2 hybridization. So that's not that likely. Well, that's not going to be a chirality center. Right? So we go to a problem. Use the rest of the stuff. There is words in the actual problem 66. You should always just try to ask yourself, what is this question asking me? And after that, try to answer the question. So the main thing of the question is R or F consideration of the chirality centers of question 66. So the first thing we have to do is find those chirality centers. So the first thing we're gonna do is we're going to analyze the molecule, right? We're gonna analyze the molecule. So we're gonna analyze it. I like to analyze it from left to right. So right here, I have this whole molecule I made for you guys, so we could break it apart and analyze it, right? So this is a benzene ring, right? Benzene. It finishes with benzene and finishes with ene. And we know that benzenes, they have double bond, because I don't know if you remember one of my videos I talk about, I think it's in the IUPAC video, I talk about the terminations. En is an alkene, so it means we have double bonds. So this goes right here, right? We're not gonna worry about that. So we have double bonds. So let's look at the benzene ring, right? We have one hydrogen, but we have double bonds. So something about double bonds, they're gonna be sp2 hybridized. So sp2 hybridized, we are not finding a chirality center, right? So after that, we get our molecule, and I'm gonna disconnect it from here so we can analyze what's going on. So after that, let's analyze this carbon. This carbon has a double bond right here, so it cannot be a chiral center, right? So after that, boom, we get to this carbon, right? So what do we know about chirality, right? About R or S. To assign R or S configuration, the hydrogen atom always has to be at the back. What does it mean? A wedge, it means the thing is facing you. For example, this is facing us. No, sorry. This is facing us, and this hydrogen is facing to the back, right? That's what this means. This is like a... So this facing back, facing to the front. That's what that means, right? So we can clearly see here our nitrogen pointing to the front, which is our H2 nitrogen. And after that, we have our hydrogen pointing to the back. So that's what we need to assign R or S. So we find that this is a chiral center, right? Because we have something that's different here, something that's different here, and something that's really different over here, right? So we're gonna start for the first atom that's attached. That was a question of mine. I was like, Jesus, bro, this molecule took me a little bit of time to make. Okay, so I was like, Jesus, like this is way bigger than this, and this is way bigger than this. What you mean the nitrogen molar mass is gonna be the most important? Because we're gonna number them from the most heavy to the least, right? So I was like, what do you mean having all these molecules that the most heavy is gonna be the nitrogen? Well, because we start numbering to the thing that's closest. So if we compare to the stuff that's closest, it's gonna be this carbon, right? It's gonna have to look like this. It's gonna be this carbon, and this nitrogen. So nitrogen compared to carbons, nitrogen is heavier, right? So that's why this is gonna be number 1, right? Okay, I hope this helped me explain better, right? So this is gonna be my right hand, and if I grab my right hand and I do this like a clock. This is gonna be the arrow, right? And the arrow is going to be going right. But if I grab my left hand and I do the arrow position, the arrow is going to be left. Right hand and I do the arrow, unless I do it backwards, but I grab my right hand and I do the arrow. You know, you have to go in the circle position. You see, if I do the arrow will be pointing this way. If I do the arrow will be pointing this way. You know which way your thumbs point. That's kind of the main idea with the S and R configuration, right? So the benzene ring is too heavy to be showing ya, but just imagine the benzene ring is here because this structure visual enough, right? So, okay, so this is how the structure looks and the benzene ring is here. We can agree that this side is bigger than this side. So this is going to be the 1 heavy atom. It's going to be 2. It's going to be 3. This is going to be 4, right? So in which way it's going to move? It's going to move to 1, to 2, to 3, to 4. So it's my right hand. If this was the heaviest, it would be 1, to 2, to 3. But no, it's R configuration. It's going to be 1, to 2, to 3. So we're going to assign the R configuration right here. Okay, so we just assigned the R configuration. So I'm getting rid of this, right? We already assigned that one. So now we have this carbon, what is attached to that carbon, and this one is a sp2 hybridized carbon, right? You have a double bond, so you skip, right? So I'm just gonna, this is my third time recording this 4 minutes of the video. It's gonna take me around 4 minutes. Why it took me so long? The first time I had a microphone problem, right? I did not knew that every time you make a cut, the microphones, they turn off. So I spoke 4 minutes without a microphone. And the second time, my phone fell off the first 5 seconds of the video. And I did not realize it fell off. So in one video, I have all the video, and the other one I have the audio. But I think I'm not following a script, and I cannot put them together. But it will be great. So I hope this one has audio and video. So anyways, enough silly business. So I think we were just explaining this, and this one has a double bond. So that's not a chiral center. And we go to the next carbon, right? So the next carbon is gonna be this carbon. So this is gonna have the number 1 priority because it has a number attached. So we're gonna name it 1, and after that, the nitrogen is a heavy element, heavier than carbon per se, and so 3. So it's gonna go 1, 2, 3. So it's gonna be pointing to the right, and that's why this one is an R, right? So let's look if the other elements are chiral centers. The other carbons are sp3 hybridized and they are chiral center. So we go to this one, and this one has a double bond, so no sp3 hybridized. This one sp3 hybridized, so it's a chiral center, right? Double bond, sp2 hybridized because it has 2 hydrogens coming off. This one is a sp3 hybridized, but you have the hydrogen, so Yes, no, chiral center, we have double bonds, and this one will have a double bond. But why did I make this one a different color? Well, this is a carboxylic acid, and I make this carbon a different color because I wanted to make the remark that whenever you see CO2H, most of the time it's going to be a carboxylic acid, and this is the structure. So you're going to have two oxygens pulling out, you're going to have a double bond to the oxygen, and you're going to have a single bond to an oxygen and a hydrogen coming out. And that's called a carboxylic acid. So we already assigned our configuration for one of the chiral centers. So now let's go to the other one. It's an example that I was explaining in the last frame of the video, right? So this is signaling that the hydrogen is coming out. So the molar mass of this sulfur right here, where is my sulfur? Okay, the molar mass of this sulfur right here is 32, and the molar mass of this nitrogen right here is 14, right? So the molar mass of this is gonna be 12, so it's gonna be right 2 pointing out. Do you notice the hydrogen is at the end? Great, you are so smart. So the hydrogens have to be at back. This is signal that it's going back, right? Jesus, but what happens if the hydrogen is not going back? Well, that's a great question, my friend. If the hydrogen is not going back, if the hydrogen is pointing towards us, right? We already say that this was a right. So we assign the same things. We go to the heavies. We are like, okay, 1, 2, 3, 4. That's a right configuration. But now we are like, okay, we have to turn this into this. So whenever we do the conversion, we have to flip the letters. So this one is now a S. So that's everything from chapter 5, R or S, configuration of chirality centers. If you want me to go more in depth, if you have any questions, about any subject, it doesn't have to be chemistry, let me know in the comments, right? I hope that the audio is better. If there is any tips to improve, let me know. Like, share, and subscribe. That was corny.